Okay, so let us look at how do we apply identities. Now the first and foremost reason you might ask is why identities? Well, the whole idea we looked at identities is to simplify the calculations and do them quicker. And how do we do them quicker? Let us explore it by doing a couple of examples. So here is the first example that we have. We are given 2x plus 3y multiplied by 2x plus 3y. Now you can use the identity a plus b whole squared is equal to a square plus b square plus 2ab. And so what will you put for a? So a becomes 2x. I've shown it over here. A is 2x and b is actually equal to 3y. So if you substitute a equals 2x, b equals 3y, we get this, right? So we get a squared. You can look at it. This is for a squared. So 2x squared plus b squared is this. So 3y is squared plus 2 twice. So this 2 is over here. A is 2x and b is 3y over here. So you have a squared plus b squared plus twice of a into b. Now when you simplify this, 2 times 2, now remember that this you have to square both the factors in this term, okay? So 2 times 2 is 4 and x times x is x squared, so you get 4x squared. Okay, then 3y squared, so 3 times 3 is 9 and y times y is y squared. You have this. Then 2 times 2 is 4, 4 times 3 is 12. So we are multiplying all the constant coefficients here. Okay, we get 12 and x multiplied by y is xy. So your answer is 4x squared plus 9y squared plus 12xy. Now it took me so many steps just because I was explaining to you how do you apply this algebraic identity. A plus b whole square is equal to a square plus b square plus 2ab. Now just try doing the same multiplication using the conventional method which I showed you earlier. That is, treat this as a binomial multiplied by binomial. You multiply this with these two and then multiply these with these two, both of these, and then simplify. It will take a lot more steps. This is very quick to come at the answer, and that's the reason why we look at identities in the first place. Now let us do another example quickly using another identity. So we have 4p minus 3q whole squared, and in this case we are going to use the second identity. A minus b whole squared is equal to a square plus b square minus twice of ab. Now what is a in this case? A is 4p and b is 3q. Remember this positive sign, a minus b, right? So there is this negative sign already there. Therefore b is plus of 3q. It's not minus 3q. You need to remember that. Okay, so all we are going to do is substitute, a square becomes 4b square, okay, b square becomes 3q squared minus, look at this minus sign over here, minus twice of a, which is 4p, and 3q is b. Now you simplify. 4 times 4 is 16, so you have 16p squared. Remember, each and every factor in this term 4p must be squared because you have to square each and all of them. Okay, so you have 16p squared. For 3q you have 9q squared minus 2 times 4 is 8, 8 times 3 is 24, so you have 24 and pq. So this is what you get. So as you can see, it was so quick to arrive at this solution just by using the identity.